Hi, my name is Vaishnavi.
And I'm Chandani.
And I'm Malika.
Together, we created BCD, a breast cancer diagnostic web application. And our project involves creating a web application that takes in data of a breast cancer tumor, and our model classifies this tumor based on the data as benign, not containing the cancer, or malignant, containing the cancer. The application will also have links to resources that will help the user learn more about the classification. Here's a quick demo of our web app. So if you enter some data about the breast cancer tumor and you click predict, the model classifies it as benign based on this data, and it also gives specific resources for the benign classification.
And right here is the back end of our web app, which includes all of the machine learning models. So right here are all the imports for the model. Here's us getting the data, and here's where the actual machine learning begins. We're actually going to first pre-process the data to make sure that everything is numeric. And then we're going to quickly analyze through the data and remove any columns that is not going to help our model. So remove any columns that have too great of a correlation with each other. So right here, you can see that we're finding those columns, we're presenting those columns here, and we're removing them here. And right here, we're going to actually split up our data into the training and testing, and 30% of our data will be used for testing. And we're also going to create two other data sets that are normalized and standardized to also be used to see if they actually help the models or if they don't help the models. And here we're actually going to create our models. So we have logistic regression, k-nearest neighbors, a decision tree classifier, and a random forest classifier. And we're going to iterate through all those models and train them based on all the different data that we have. So this first one is for the normal data, this one is for the standardized data, and this one is for the original data. And you can see here that the best performing model was the logistic regression trained with standardized data. We got a 99.4% accuracy with our data set. And with this information, we can now choose this model as our best model, which will then be used for our web app.
So now that we have the backend through our AI model, we needed to find a way to connect this to our front end, which is made in HTML. So in order to do this, we had this middle ground of using Flask in our app.py file. So we had Flask, which is a web framework, and it allows us to connect our Python with our front end. So here we have this home function, which allows us to send all the data to our index.html and launch that page created by that HTML file. And then here our predict function allows us to get the data from the user, send that data to our AI model, and then output the result.
To design our user interface in our HTML file, we included a JS script section and a CSS style section. And in our JS style section, script section, we have a method that, based on the classification that the model sends back, we send out specific resources for that classification.